What is IoT versus M2M, CPS, what? In the introductory chapter of my Internet of Things, IoT, tutorial I listed a number of technologies that are very closely related to IoT. These included machine-to-machine, M2M, communications, cyber-physical systems, CPS, and the Web of Things, what? Indeed, these technologies are very commonly used to describe IoT applications and have certainly some overlapping aspects to IoT. Nevertheless, there are some subtle differences between IoT and these technologies, which researchers and engineers had better have in mind. In this post, I am trying to provide some insights on the differences between IoT and these technologies based on literature texts, but also my experience from projects and application deployments. Prior to discussing these differences, it's good to bear in mind that IoT is probably used more widely than these other terms and technologies, mainly due to its generality and consumer friendliness. Also, IoT has been successfully disseminated and marketed during the past 10 years and hence tends to be more widely recognizable and acknowledged. IoT versus M2M. M2M refers to communications and interactions between machines and devices. Such interactions can occur via a cloud computing infrastructure, example, devices exchanging information through a cloud infrastructure. M2M offers the means for managing devices and devices interactio, while also collecting machine and/or sensor data. M2M is a term introduced by telecommunication services providers and pays emphasis on machines' interactions via one or more telco communication networks, example, 3G, 4G, 5G satellite, public networks. Hence, M2M is part of the IoT, while M2M standards, such as 1M2M, have a prominent place in the IoT standards landscape. However, IoT has a broader scope than M2M, since it comprises a broader range of interactions, including interactions between devices, things and people, things with applications and people with applications. It also enables the composition of workflows comprising all of the above interactions. IoT includes the notion of internet connectivity, which is provided in most of the networks outlined above, but is not necessarily focused on the use of telco networks. IoT versus CPS. CPS the highest degree of overlap with IoT. In my view, most of the CPS systems applications could well be classified as IoT systems and vice versa. Of course, it all depends on the definition and perception about these terms and technologies. Both CPS and IoT are networked systems and likely to involve physical sensing and/or embedded devices, i.e., both combine aspects of the physical and digital cyber worlds. Nevertheless, different communities favor one term over the other and use the two terms differently. For example, CPS is commonly used and preferred over IoT by the engineering communities, example, mechanical engineering, aerospace engineering, aeronautics. It is also used extensively by computer scientists working on embedded systems and systems testing and verification. Also, CPS is preferred over IoT in USA. IoT is commonly used and preferred over CPS by the telecommunications and networking communities, including computer scientists that work on the broader areas of next-generation networks and future Internet. In EU, IoT tends to be used more than CPS, although the latter is gaining popularity in areas such as future manufacturing, example, Industry 4.0 initiative. I usually use the term CPS in the case of systems problems that involve large-scale real-time control, example, time-critical problems, notably problems that combine control of combined organizational and physical processes. I would use the term IoT for problems that collect and process sensor data, including IoT analytics problems systems, without essentially involving real-time control. I also tend to use CPS where referring to systems involving networks of embedded systems and tight human-machine interactions. I stick to IoT when the target system's apps involve internet connectivity only. IoT versus what? While IoT is about creating a network of objects, things, people, systems and applications, what tries to integrate them to the web. Technically speaking, what can be thought as a flavor option of an application layer added over the IoT's network layer. However, the scope of IoT applications is broader and includes systems that are not accessible through the web, example, conventional WSN and RFID systems. From a developer's perspective, the what enables access and control over IoT resources and applications using mainstream web technologies such as HTML 5.0, JavaScript, AJAX, PHP, Ruby on Rails, etc. The approach to building what is therefore based on RESTful principles and REST APIs, which enable both developers and deployers to benefit from the popularity and maturity of web technologies. Still, building the what has various scalability, security, etc. challenges, especially as part of a roadmap towards a global what. Overall, terms such as M2M, CPS and what can be commonly and aptly used instead of IoT in a variety of contexts. However, I would not call them synonymous to IoT, while I still think IoT is likely to be the prevailing term due to its popularity among consumers.